Alright, hello everybody. This time I decided to do question 83 out of section 2.7 on page 218. And what they ask us to do is find a savings account that earns 5% interest that's compounded annually. If we invest X amount of dollars in such an account, then the amount that we have is A of X is equal to the amount invested plus 5% interest, which equals A of X. And we're asked to find multiple compositions of A. And then we're asked, what do these compositions represent? And then we're asked to find a formula for what we get when we compose n copies of A. So what we'll start off with is A composed of A. Which what we have with this is where A of X is equal to 1.05x. What we have with A composed of A would be 1.05, where the next function becomes what x was in the previous function. So this becomes 1.05x. And then we're asked to find A composed of A composed of A. And this will be the first function replaced by the next function replaced by the next function, and close all our parentheses. And we're finally asked to find A composed of A composed of A composed of A. And we do see a pattern start to emerge here. It's the original function with x replaced by the next function, which that x is replaced by the next function, and that x is replaced by the final function. And we'll go ahead and close all our parentheses there. So that's what we have when we have A composed of A composed of A composed of A. And we actually see a pattern start to emerge here. Which that pattern, what these compositions represent, is actually multiple years of compounded interest. So what we have here is 4 years of compounded interest on the original principal value. And a formula for what we get when we compose n copies of this A is actually going to be an exponential representation. So what we would actually have in this would be the principal x times the rate of interest to the nth power, because of the fact that we have multiple multiplications of the same function. And we can actually test this. I'll give myself a little bit more room here. Say we actually invested $1,000 into a savings account that earned 5% interest compounded annually. So at the end of the first year, which would be this function A of X, in the first year would equal $1,050. If we did A composed of A, which would be 2 years of compounded interest, we would get $1,102.50. A composed of A composed of A, which is 3 years of compounded interest, would actually give us $1,157.63. And finally, for the fourth year of compounded interest, A composed of A, composed of A, composed of A, equals $1,215.51. Now, if we were going to test that versus our formula for what the representation of all these multiple compositions of A, which is x, the principal, times the rate to the nth power number of years, what we would have is our principal, 1,000, times our rate to the fourth power, since it's compounded by 4 years. And what we find when we actually do the math out on that is that you have $1,215.51. And this is actually very close to what the actual compound interest formula is, where you have your principal. In this particular instance, it would be your principal times 1 plus our rate times the number of years. And the only thing it would actually be missing would be the rate divided by the amount of times it's compounded annually to the power of the number of times it's compounded annually times the number of years, which is actually the compound interest formula. So this is a very simple version of that formula. And it's broken down when we see the multiple compositions of A. Okay, thank you.